Hello there. Today is the special edition of the IT World. I will not be doing most of the talking. Instead, I will be showing to you a compilation of the best answers I have received for several questions regarding several topics. You will know some of the insights of our followers, anything related to data communications.
From this group of networks, the point-to-point and the multi-access. In point-to-point, the packet needs to be stored at station until it reaches final destination when sending a packet. While in multi-access, the whole packet is broadcasted in a single shared channel that can cause collision. But when there is a collision, none of the station will receive anything that was sent, so all of it will be lost and all the packets broadcasted will be wasted during the collision interval. So to rectify this problem, multi-access technique was implemented, and one of most of four techniques is fixed assignment technique. Under this, we have FDMA. Each station is allocated a band to send its data. This band is reserved for that station for all the time. The frequency bands of different stations are separated by small bands of unused frequency. To avoid overlapping, a guard band is placed in between frequency bands. The second is TDMA. Each station is allocated a time slot during which it has to wait for its own time slot before it can transmit. Each station must know the beginning of its slot and the location of its slot. To avoid overlapping of transmission in time, a guard time may be placed in between time slots. Lastly is the CDMA. It is also called spread spectrum multiple access because the transmission could spread throughout the allocated bandwidth. With this, all stations can transmit data simultaneously. In comparison with FDMA and TDMA that assign time slot and frequencies, in CDMA it has its own frequency hopping pattern determined by a binary code.
Aloha. Let's talk about that. So Aloha is actually an acronym for Additive Links Online Hawaii Area. It was intended to provide cheap access to time-sharing systems to a large number of users. It was developed in University of Hawaii, hence the term Aloha, which is a greeting term there. So there's two versions of it. I'm going to be tackling on the first one, which is Pure Aloha. Pure Aloha allows stations to transmit frames whenever they have data to send. And if the data they send failed, they retransmit the frame again after a random interval. Emphasis on random, otherwise the collision is expected to occur again. So the rectangle here represents the frame, and when they overlap for each station, a collision is expected. The vulnerability period is 2t, t being the time it takes for the frame to be sent. Because if you look at B, if it was just sent a little bit earlier, then the collision would have been avoided. For the throughput, researchers have arrived with this equation, and it results to 18.4%. It's pretty low because, as we've learned, it's going to be prone to collision. So that's pretty much it for Aloha. Thanks for having me.
Well, pure Aloha may be a good random access technique, but there are others which are far better than it when it comes to channel utilization, like the slatted variant of it, which uses time slots to designate channel usage of every node in the network. There is also a technique called CSMA, which checks the channel first if it is busy or not before it transmits a message, thus preventing to overwhelm it. It also have a variant which supports collision detection, which I think is the best since it quickly aborts the message transmission in an event of collision. To prove my point, this illustration represents the techniques in order, which are Pure Aloha, Slatted Aloha, CSMA, and CSMA with collision detection. The shaded rectangle represents collision, and you will notice that as you move down from one technique to another, the channel utilization is getting better. And that is why I believe that CSMA with collision detection is the best among the random access techniques. Thank you.
Yes, that's Ray Rivera and Angelito Zardes. Let us now listen to Dorothy Gracilia and Wilma Bullo.
Besides the rigid control of fixed assignment technique and the collision-prone random access technique, there is a third technique of medium access protocol that is a demand assignment technique. In demand assignment, Continuous connection of the station to the network control system is not required, and channel allocation is based on the demand of the station. There are two types of demand assignment that will be discussed here. Allow me to explain central control. In this type of demand assignment, a central controller decides which channel to allocate to a requesting station. Under central control, there are the polling systems and the circuit-oriented system.
Thank you. Now, we will be talking about polling stations of demand assignment technique. In polling station, a central controller polls each station on the network, one by one requesting the polled terminal to transmit. If the polled terminal doesn't have anything to send, it gives a negative or no reply to the central controller. Otherwise, it submits. When the polled station is done, the central controller proceeds to poll the next station and the process repeats. The central controller has the complete list of stations to poll. Polling requires constant use of the channel as the central controller polls each station. On the other hand, in a circuit-oriented system, this scheme uses frequency division multiplexing or time division multiplexing subchannels that are assigned based on demand by a central controller. An example is the SPADE satellite system that allocates a pool of frequency subchannels. A ground station requesting to transmit selects an unused channel randomly. If the request is seen on the downlink, it means the channel has been allocated for that station by central controller and the other station should abstain from using it. If a collision occurred in the request for allocation, the stations should try again later. When a station is done using a subchannel, it sends an allocating message to the common message.
Good day, everyone. Another class of demand assignment technique is the distributed control, which requires all stations to execute same algorithm for coordinated actions. It is more desirable for two main reasons. First, its reliability due to the absence of central controller. There is no central controller, which is a single point of failure. The second is its improved performance. There are several kinds of distributed control, but we will focus on the three, and they are Reservation Aloha or our Aloha round-robin reservation scheme, and FIFO reservation scheme. In the Reservation Aloha system, the contention is limited to the short reservation subslots, while the transmission in the message slots is contention-free. In the R Aloha scheme, the control of the system is distributed among all users in the network. Because all reservation messages are heard by all users in the network, each user maintains information on the queue of outstanding reservations for all other users in the network as well as for its own reservation. In the figure shown, Reservation Aloha has two modes of operation, unreserved mode and reserved mode. In the unreserved mode, the time axis is divided into short equal-length subslots for making reservations. In the reserved mode, the time axis is divided into fixed-length frames. When there are no reservations taking place, meaning the queue length drops to 0, the system returns to the unreserved mode, in which there are reservation subslots only. The scheme, therefore, can be viewed as combination of slotted Aloha and TDMA protocols. On the other hand, in the round-robin reservation scheme, there is a fixed TDMA assignment of stations to slots. The difference with pure TDMA is that unused slots are assigned to active stations. This can be viewed as TDMA plus pure Aloha.
Hi there. Now we proceed with the last of the techniques. First off is the FIFO reservation technique. So this one's under Demand Assignment Distributed Control. It stands for first in, first out, and as we can recall from data structures, it's in the form of a queue, wherein the first one that enqueues is the first one that queues. So in this scheme, reservations are made explicitly by the stations, which make data slots free of conflict. To illustrate, we have data slots represented by the squares, and the reservation slots are noticeably smaller as they just provide dibs as to what data slots will be sent next. Finally, we have mixed strategies, which is the last of the medium access techniques. It's a mixture of several methods or techniques, and they adapt to the varying demands. So one example is the satellite system. In the uplink, it utilizes slotted Aloha, and for downlink, TDMA. And as always, thanks for having me.
Yes, we're back. And those are very interesting insights. And now let us listen to this wonderful interview answer regarding IEEE 802.3.
IEEE 802.3. Yes, I think I've heard of that. Isn't that like the most popular local area network standard that's a lot similar to the Ethernet? As far as I remember, it uses the one persistent CSMACD. So stations transmit when the channel is available, but if it's not, they wait until the channel is free and then immediately transmit. Oh, but it means there might be collisions, right? So when that happens, the station send a jamming signal so that everyone else knows to cease transmission, and then the station will schedule a reattempt using this binary exponential backoff algorithm like this. So first, they determine if the transmission attempt is still within the backoff limit. If yes, then they get the lower of this number and the number 10. So like if it's retransmission attempt number 4, since 4 is less than 10, it's going to be 4. And then they raise 2 to this number. So in our example, it's 2 raised to 4, that's 16. And then they generate a random number between 0 and 16, multiply that random number by the slot time, and the result is going to be the retransmission delay. Is that the information you were asking about?
Another popular IEEE standard is the IEEE 802.5 token ring, which makes use of ring topology. It's the oldest ring control technique dating back to 1969 and was back then referred to as the New Hall ring. The ring topology looks something like this. It's similar to a bus, except that the endpoints are connected so that it forms a closed loop. Ring interfaces connect the stations to the ring. A token is a bit pattern that circulates the ring when all stations are idle. A station that wants to transmit will seize the token ring and invert a single bit to signal the other stations that it has been taken. Since there is only one token, only one station can use it at a time. The station that captures the token will transmit other information like address and data, and other stations will determine if the data is for them. If yes, the station will receive the frame by going into transmit mode, otherwise it will put the frame back into the ring with 1 bit delay. Only the source station can remove the frame of the ring. If, say, due to some error this was not done, another station called the active monitor can detect that the frame has already traversed the ring twice and take the frame of the ring. Hence, during light traffic, the token will spend most of its time circulating, while during heavy traffic, it will be captured immediately by the next station, resulting in efficiency nearing 100%.
Yes, that is Monica Salazar that you have just watched. And now let us listen to additional presentations related to IEEE.
Basically, it has two types that are used, the tokens and the data frames. The token is 3 bytes long and consists of a start frame delimiter. It alerts each station of the arrival of a token. The access control byte that contains the priority field, the token beat, the monitor beat, and the reservation beat. The end frame delimiter signals the end of the token. This field also contains beats to indicate the damage frame and identify the frame that is the last in the logical sequence. The data frame format has the same field as token frame but with several others, the starting delimiter, the access control, but this has frame control that indicates whether the frame contains data or control information. The destination and source address consists of the two 6-byte address fields that identify the destination and source station addresses. The data that has a variable length field of 0 or more bytes. The frame check sequence that is filled by the source station with a calculated value dependent on the frame control. The ending delimiter, and lastly the frame status field, which is a 1-byte field that terminates the frame and includes 1-bit address recognized and frame copied fields. That is basically what 802.5 has.
IEEE 802.5 Physical Layer Specifications. The IEEE 802.5 requires physical layer networks to use unshielded twisted pair cabling or shielded twisted pair. Data rates originally specified network speeds of 4 Mbps but later was increased to 16 Mbps, which was introduced by IBM. Signals usually follow differential Manchester encoding ranging in a magnitude of 3 to 4.5 volts or high-low and low-high for each bit. With 802.5, it uses high-high and low-low to mark the start and end of each frame. The actual use, topology token ring networks use a logical ring topology and most often a physical star. The logical ring is often created in a multi-station access unit. Token passing is the access method which 802.5 uses. On a token ring network, only one computer at a time can transmit data. When a computer has data to send, it must use a special type of packet known as the token. The token travels around the network looking for computers with data to send. The computer's data is passed along with the token until it gets to the destination computer, at which point the data is removed from the token and empty token will be placed back on the ring.
Those are very interesting additional insights regarding medium access protocols and IEEE, brought to you by Maria Elisa De La Rosa and Gino Ako. Now, let us proceed to another interesting topic, the network layer, starting with an interesting presentation from Gemfriel De La Cruz and Francis Montemar.
The network layer is responsible for determining the most appropriate path from the source to the destination. In terms of layers, the network layer is the third layer. It is the network layer that supports the operation of the transport layer. It offers two types of services, namely the connection-oriented service, which works by first establishing a virtual circuit. Second is the connectionless service, in which it merely sends a packet in hopes of it being routed correctly to the destination. How does it do this? Through routing algorithms. There are two types. The first is static, which sets a fixed path for transmission. The second is dynamic, which can make the path change according to prevailing network conditions. So, there are plenty of routing algorithms out there which choose their path depending on different factors, such as channel utilization, transmission time, or physical distance. Okay, that's all I know. Maybe you can ask the next guy for more details.
Let's proceed to the state routing protocols, also known as the shortest path algorithm, and are built around the GSTA's shortest path first algorithm, commonly used routing for open standards. These state routing protocols have a reputation of being much more complex than their distance vector counterparts. However, the basics, functionality, and configuration of these state routing protocols is equally straightforward.
That's some great information you have just watched from Jem and Francis, two great guys. Let us now proceed with three additional insights from our contributors.
Hi, my name is Jasmine and welcome to IT Word Special Edition. Today I'll be reporting about internet networking and the internet protocol. So after learning that there are different types of networks, a technique called internet networking is used to interconnect two or more networks. So to aid this, there are internet networking devices, and the most popular ones are the router, the bridge, and the repeater. The router is known to be the most intelligent one. What it does is it transfers packets from one type of network to another with different protocols. The bridge can store and forward data links from one LAN to another, while the repeater strengthens the signal to minimize signal degradation. This is ideal for long-distance transmission. So there are four major functions of the Internet Protocol diagram. These are to provide basic unit for data transfer, provide addressing, facilitate routing, and perform fragmentation. It also offers connection to service. It encapsulates the data and delivers the packets using the best effort system, and it does not inform the status of a packet. What it does, it will only just deliver and not make up for loss of damaged packet.
RFC 1594 defines the term datagram as a self-contained, independent entity of data carrying sufficient information to be routed from the source to the destination computer without reliance on earlier exchanges between the source and destination computer and the transporting network. Datagram has two components, header and data payload. Herewith is the parts of IP datagram. Let's proceed to addressing. Every IP datagram should identify its origin and its target. This is specified in the source and destination address field. No two machines connected to the internet can have same address. Its address field is 32 bits wide, divided into 4 octets, and it contains the network number and the host number. It uses 3 different types of addressing to move data throughout an internet network: data link layer, network layer, and port address. Let us proceed to subnets. Subnets is a logical subdivision of an IP network, and the practice of dividing a network into 2 or more networks is called subnetting. Computers that belong to a subnet are addressed with a common, identical, most significant bit group in their IP address. This results in the logical division of an IP address into two fields, the network and the host identifier. Herewith is how the host number is being divided into host number and subnet number. Thank you. Bye-bye.
Hi, I'm Jason and I will report about TCP and transport layer. The transport layer provides a reliable mechanism for the exchange of data between processes and different computers. By doing so, it relieves the higher layer software of the burden of managing the underlying communication facility. There are two protocols which do this, TCP and UDP. TCP is the connection-oriented transport layer protocol of the Internet. It aims to provide reliable end-to-end stream between two hosts in an unreliable multi-network. TCP segment header. TCP entities send and receive data in the form of segments. A segment consists of a header, followed with or without the optional part plus the data. The services that TCP provides are connection establishment, maintenance and termination, packet delivery using acknowledgement, packet ordering using sequence numbers, error control, and allowing multiple connections using ports.
Well, you have just heard from Heather, Jasmine, Rogelio, and Jason. Let us now listen to Vanessa and Janine.
TCP is no doubt reliable for connections. The connection establishment is done in a three-way handshake. Step 1. Client N initiates an active open by sending a message with an active sync bit and the sequence number of N to the server waiting for a connection request while in a passive open state. 2. The server X sends a reply with an active sync bit, the sequence number of X plus the acknowledgement bit of N plus 1, which is the next expected sequence number of N. Number 3, the client receives a message and returns the expected sequence number and an acknowledgement bit of X plus 1. Voila, connection has been established. Terminating the connection also happens in 3 steps. 1. The client sends a message with an active FIN bit. 2. The server sends back a message with an acknowledgement and the FIN bit set. 3. The client will reply back with an acknowledgement. The connection is closed.
So what is the role of UDP in transport layer? User Datagram Protocol is a connectionless transport protocol. It is a very simple and fast protocol. It is a good protocol for data flowing in one direction but does not guarantee order delivery of data, which makes it unreliable. Let's take a look at the UDP header.
The source port is process port number of originating station while destination port or receiving station. This port will depend on what program we're going to run. For example, if we are running DNS, the destination port will be 53. If network time protocol, port will be 123. Length field indicates the length of the header and the data in terms of bytes. Checksum used to check the validity of the header and the data.
In general, transport layer is the first one which breaks the information data supplied by application layer into smaller units called segments. This layer provides end-to-end delivery of data between hosts which may or may not belong to the same subnet. All server processes intend to communicate over the network equipped with well-known transport service access points, also known as port numbers. The protocols on this layer are TCP for connection-oriented and UDP for connectionless.
So that's it. I'm very thankful for all your insights and answers for our subject matter for this special edition. And to wrap up this program, since this is the special edition, instead of only one word for the day, it will be words for the day.
These are the terms that are bound to be helpful. Technical terms. Domain name system is the protocol that provides the framework for web browsing. World Wide Web is a collection of linked documents spread out through remote sites in the Internet. Uniform Resource Locator is the address of a specific web page or file on the Internet. HTML is hypertext markup language, authoring language used to create documents on the World Wide Web. Hypertext Transfer Protocol is used to transfer data over the web. File Transfer Protocol is a protocol designed for transferring files over the internet using an FTP client such as a web browser. Telnet, short for Terminal Network, is a remote network protocol used to provide a command line interface for communicating with a device. Electronic mail is an internet service allowing people who have email address to send and receive electronic mail letters. And every email address has two main parts, a username and domain name. Username comes first, followed by an @ symbol and followed by the domain name. Those are the technical terms for this special edition.
The contributions are part of a contest for our IT Word Special Edition. Since this is the special edition, there were questions asked prior to this video cast, and the one with the most contributions will win an IT Word Special Edition t-shirt courtesy of Agelos Imprint Printing Services, our major sponsor for this videocast. And the winner will be announced on our next videocast. Thank you for watching and have a nice day.